Welcome students in this beautiful session electromagnetic spectrum. So let's begin the topic electromagnetic spectrum. Students, the meaning of electromagnetic spectrum is this is the orderly arrangement of wavelength, or we can say frequency, is known as electromagnetic spectrum. Students, as we know, we have a different kinds of waves in the electromagnetic wave. What that waves are, there will be a short trick for that. Cox-U-Wimmer. So that this is not the part of our syllabus, that is a cosmic wave. Next one is a gamma rays. Then X-rays. Then we have ultraviolet rays. Okay. Next, visible rays, infrared, micro, and radio waves. So these are the set of arrangement of a wavelength of a different kind of electromagnetic waves. These are known to be a electromagnetic spectrum. So one by one we will take all these particular things. Like first we will take radio waves. What are radio waves? Radio waves, electromagnetic wave of wavelength longer than 1 meter are called as radio wave. Means this is a type of electromagnetic wave whose wavelength is longer than 1 meter. Students, in the previous session, like in the electromagnetic wave session, we saw different spectrums or different types of waves and their wavelength range also. So among that wavelength, this is also mentioned where radio wave have a greater than 1 meter. This is the radio waves. So these waves are produced as the result of charges accelerating through conducting wire and generated by electronic device like LC oscillator. So by the LC oscillator we can produce radio waves. Since these waves have a long wavelength, so they can spread around hills and buildings by diffraction. These are used for radio, TV, telephone and satellite communication. In nuclear magnetic resonance imaging, radio waves, frequencies from few hertz up to 10 to the power minus 9 hertz. Corresponding wavelength are from about 10 to the power 8 meter to few centimeters, usually produced by AC circuit attached to an antenna. A simple wire can function as antenna. Antennas containing multiple conducting elements are usually more efficient and more common. Radio waves can be detected by an antenna similar to one used for generation. Parallel wires can act as an antennas. The AC current in the antennas are produced by time-varying electric field in the antennas. This produces a time-varying magnetic field and EM waves. As the current oscillates, time-varying or a time with the charges are accelerated. In general, when an electric charge is accelerated, it produces electromagnetic radiation. Radio waves are produced by accelerated motion of charges conducting in the wire. They are used in radio and television communication system. They are generally in the frequency range 500 kHz to about 10 or 1000 MHz. The AM amplitude modulated band is from 500 kHz to 1710 kHz. Higher frequency up to 54 MHz are used for short wave bands. TV wave range from 54 MHz to 890 MHz. The FM frequency modulation radio band extended from 88 MHz to 108 MHz. Cellular phones used wave to transmit voice communication. The ultra high frequency UHF band. Low frequency waves, the AM band. Radio waves having wavelength of 10 meter or more, frequency less than 30 MHz are said to constitute the AM band. The lower atmosphere is transparent to these waves, but the ionosphere reflects them back. A signal transmitted from a certain point can be received at another point in two possible waves directly along the surface of the earth, called ground waves, and after reflection from the ionosphere, called sky waves. So this is a question. Okay, there is a little bit issue, so the answer is given. So the question is also very easy. Electromagnetic waves of wavelength longer than 1 meter is required. We already know that is a radio waves. And the frequency range of a microwave is 10 to the power 9 Hz, 10 to the power 12 Hz. Next we have a microwaves. Electric magnetic waves. Electromagnetic or electric magnetic, these both are the same terms. So electric magnetic waves with wavelength in the approximation range 1 millimeter to 0.3 meter are called as a microwaves. The frequency range is 1 gigahertz to 3 gigahertz. They have a long frequency range discovered by Hertz. These are produced by special electronic devices like klystron and magnetrons. Because of their short wavelength, they can travel in a beams in a signal. These are used in radar system for aircraft navigation. For studying atomic and molecular properties of a matter, we also use microwaves. Used in radar and telecommunication. To analyze the fine detail of the molecular structure. Microwaves based on the microwaves speed guns design which are used time fastball and in tennis serves and automobiles. Microwaves produces heat when absorbed by matter. Microwaves oven is a domestic appliance to cook food item. Water molecule vibrate in the frequency of order microwave frequencies. Frequency of water molecules is 3 gigahertz. The frequency of a microwave is selected to match resonant frequency of a water molecule. When such waves are passed through water, the kinetic energy of the waves are efficiently transferred to water molecule. This raises the temperature of the water. This raises the temperature of the food containing the water. The food material are to be placed in the porcelain container. The molecule at the porcelain container vibrate with such smaller frequencies. Because of a large molecule vibrate with the smaller frequencies, so they cannot absorb microwaves. They only absorb they only affected by the frequencies. Hence, container is unaffected and it becomes cool. When a metal container is used, it accumulates some charge and there is a danger of getting shocked when touched. The heat developed in a container may sometimes melt. Basic. The microwave speed guns are designed which are used for time fast ball and in the tennis serves and automobiles. Microwaves have frequency range 10 to the power 9 Hz to 10 to the power 12 Hz. Correspondingly, wavelengths are from few centimeter to few tenth millimeter. This is a microwave. I hope you ever saw this device. So micro ovens generated radiation with frequency 2.5 10 to the power 9 Hz. The microwave energy is transferred to water molecule in the food and heat of the food. Microwave oven is a domestic appliance to cook the food item. All food items contain water as constituent. When the temperature of the body rises, the energy of the random motion of the molecule and molecule increases. The molecules travel and vibrate or rotate also with the high energies. So when the frequency of a rotation of the water molecule is the 3 gigahertz, the frequency of the microwaves is selected and that will be matched to the resonant frequency of the molecules. Students, as we know that the frequency of a microwaves, as we heard, like this will be water molecules for the 3 gigahertz. That will be a particular range. This will be a very high particular range of frequency. Because of that vibration, a heat will be generated. When such kind of wave passes through water, kinetic energy of a wave efficiently transferred to the molecule and gives rise to the temperature also. And the food of the material also be maintained. So the molecules in the procellulin vibrate such kind of frequencies. Because of that, molecules get large amount of heat. There will be no absorb in the microwaves. Because of that will be unaffected. And as we saw earlier, if we use these kind of a thing in a metal, so person may get shocked. And because of the heat developed in the container, sometimes that will be met. It convert the heat in the vessel. So because of that burner, the food inside firstly prepared and transfer the energy in the vessel. So one by one we see like electromagnetic wave with the wavelength is approximate range 1 millimeter to 0.3. What are these? Yes, your answer is correct, microwaves. Microwaves are produced in special electronic devices which we called as a klystron, magnetron, cyclotrons, both A and B. Yes, both A and B. Infrared rays. What are infrared rays? Electromagnetic waves ranging all wavelengths from short range of a microwaves. They have a red limit visible light. Little bit a red limit of a visible light. That's why we are called as infrared rays. So they have a wavelength range 0.7 micrometer, about 1 centimeter. To detect infrared rays, thermocouple or thermopiles, bolometers, photoconducting cell are used. Properties of this: infrared rays are electromagnetic waves and travel with the speed of a light. Infrared rays obeys the law of reflection and reflection also. Infrared rays can produce interference and can be polarized also. When they allow to fall matter, infrared rays produce to increase the temperature. Infrared rays affect the photographic plate also. When absorbed by molecule, the energy of infrared rays get converted to the molecular vibration. And they are selected or scattered less comparable to the visible light by the atmosphere. Hence, infrared light can travel through the long distance also. For that, so we can say that atmosphere under condition of smoke, fog, etc., nitrogen or oxygen gases are found to be transparent medium in all wavelength of a transparent, like because of infrared rays. Application: infrared rays from sun keep from the earth warmth and help sustain life on earth. The coal deposited in the interior of the earth are a result of a conversion of forest wood into coal due to the infrared rays. Infrared rays are solar water heater and coolers. Infrared rays are used for taking photographs during the condition of fog, etc. Infrared rays absorption spectra is used to study the molecular structure and then check to purity of the chemicals. Infrared rays are used for producing dehydrated foods. Infrared rays are used to provide electrical energy to the satellite by using solar cell. And infrared rays are used to treat the muscular strain also. Infrared rays has a frequency 10 to the power 12 Hz to 410 to the power 14 Hz. Wavelength, as we know, this is a few tenths of a millimeter, a few microns also. We sense this radiation as a heat. Black body radiation from object near room temperature fall into this range. Also useful for monitoring the Earth atmosphere. Electromagnetic wave ranging from short wavelength and of the microwaves to red limit of visible light are called as ultraviolet waves, infrared waves, gamma waves, or a microwaves. The correct answer for this question is infrared waves. Next, infrared waves obeys laws of reflection, refraction, interference, all of above. The correct answer for this question is all of them. Ultraviolet rays. What are ultraviolet rays is? Ultraviolet rays. UV rays is an electromagnetic radiation beyond the violet and the visible spectrum. Its wavelength range is approximately 380 nanometer to 0.6 nanometer. Properties. Ultraviolet rays are electromagnetic waves and travels with the speed of 310 to the power 8 meter per second, means the speed of a light. This obeys the law of reflection and refraction. They can also undergo interference and can be polarized. When allowed to fall on metal, they causes emission of photoelectrons. They can affect the photographic plate also. Ultraviolet rays can use fluorescence in certain metals. What is the meaning of fluorescence? A lightning in a certain metals. Ultraviolet rays cannot pass through a glass, but quartz, fluoride, and rock salt are transparent to them. Ultraviolet rays process the properly synthesizing vitamin D when skin is exposed to sunlight. Application. Ultraviolet rays are used to checking the mineral samples by making use of its property by causing fluorescence. Ultraviolet absorption spectra is used to study the molecular structure. Ultraviolet rays destroy the bacteria, hence we use a sanitizing surgical instrument also. As ultraviolet rays can cause photoelectric effect, they can use in burglar's alarms. Ultraviolet light has a frequency about 810 to the power 14 Hz to 810 to the power 17 Hz also. Corresponding wavelength are about 3 nanometer to 400 nanometer. The UV portion of the spectrum is commonly subdivided into several regions. UVA 350 nanometer to 400 nanometer, UVB 280 nanometer to 315 meter, UVC 200 nanometer to 80 nanometer. Greatest potential for damaging tissues. Now with the question, sir, ultraviolet rays can cause, which are the used vulgar alarms? Interference, reflection, refraction, or a photoelectric effect. So the answer is a photoelectric effect. The wavelength range of UV rays is approximately 380 nanometer to 0.6 nanometer, 0.7 micrometer to 1 centimeter, or 1 gigahertz to 30 gigahertz, none of these. 380 to 0.6 nanometer. X-rays and gamma rays. Now, moving ahead, what is X-rays? X-rays. X-ray are electromagnetic waves with wavelength in the range of approximately 10 nanometer to 10 to the power minus 4 nanometer. These are produced when high energy electrons bombarding a metal target. These are very penetrating and dangerous. These are used to study crystal structure in the treatment of certain forms of a cancer also. What are gamma rays? So gamma rays, these are electromagnetic waves of the uppermost frequency range of the known as electromagnetic spectrum are called as gamma rays. Their wavelength range is approximately -10 to the power minus 1 nanometer to less than 10 to the power minus 5 nanometer. These are produced in certain nuclear reactions. Cosmic rays from outer space is also a major source of gamma rays. They have same properties as that of X-rays. These are used to find flaws in the metals and sterilize equipment. These are used to kill cancerous growths. Now some questions are, X-rays are produced when dash electrons are bombarded with a metal target. Low energy, high energetic, low momentum, none of these. The correct answer for this question is high energetic. So X-rays are produced when high energetic electrons are bombarded with a metal target. The electromagnetic wave of frequency range of electromagnetic spectrum are called gamma rays. Lowermost, uppermost, visible, none of these. The correct answer for this question is uppermost. Propagation of radio waves. So, how does the propagation of radio waves takes place? Propagation of radio waves. Low frequency waves, the AM band. Radio waves have wavelength 10 meter or more than are said a constituent the AM band. Frequency less than 30 megahertz. So lower atmosphere is a transparent to these waves, but ionosphere reflect them back. A signal transmitted from a certain point can be received at another point to possible waves directly along the surface of the earth. That is called ground wave. And after reflection from ionosphere called sky waves. Waves having frequencies up to 1500 kilohertz. That means waves length above 200 meter are mainly transmitted through ground because low frequencies sky waves lost their energy very quickly to the ground wave. Therefore, higher frequency are mainly transmitted through the sky. The two reasons of the AM band are called medium wave and short wave respectively. High frequency waves, television transmission. So above the frequency 30 megahertz, the ionosphere does not reflect the wave towards the earth. So the television signals have a frequencies range 100 to 200 megahertz. Therefore, TV transmission via sky is not possible. only direct reception via the ground is possible. Therefore, in order to have a larger coverage, the transmission has to done through very tall antennas. The height of the transmitting antennas for TV telecast is given by H is equals to D square to RE, where D is the radius of area to be covered for TV telecast and RE is the radius of Earth. The television signal have a frequency in the range of, the correct answer is 100 to 200 megahertz. Waves having frequencies of about 1500 kilohertz are mainly transmitted through ground because low frequency sky waves dash quickly than the ground waves. Options are gain their energy, lost their energy, conserve their energy, none of these. The correct answer for this question is lost their energy, means waves having frequency about 1500 kilohertz are mainly transmitted through the ground because of low frequency sky waves lost their energy very quickly than the ground waves. So students, this is all for today. I hope you learned that what is the mean of electromagnetic spectrum, how the electromagnetic waves formed, what are their applications of electromagnetic waves, and how to apply the electromagnetic waves in the daily life. Students, these are for the today's class. I hope you enjoyed the class. So, take care everyone and wait for the next video.